In this lesson, we're going to be learning how to determine the eigenvalues and eigenvectors of a 3x3 matrix. So here is the question. If A is equal to this matrix, in row 1 we have 1, 0 and 4. In row 2 we have 0, 2 and 0. Then in row 3 we have 3, 1 and negative 3. Then we ask to determine the eigenvalues and eigenvectors. Now in the formula for eigenvalues, we are going to determine the eigenvalues first. And the formula for eigenvalues is determinant of matrix A minus lambda times identity matrix equals to 0. Now we are going to apply this equation to this matrix. So we have determinant of matrix A, which is 1, 0, 4, 0, 2, 0 and 3, 1, negative 3, minus lambda multiplied by identity matrix is going to be 3 by 3 identity matrix. So we have 0, 0, 1 here. Then this is equals to 0. Now we're going to have 1, 0, 4, 0, 2, 0, 3, 1, negative 3, minus lambda times 1 is equals to lambda times 0 is equals to 0, lambda times this 0 is equals to 0, lambda times 0 is equals to 0, lambda times 1 is equals to lambda times 0 is equals to 0. Then this one will be 0, 0, and then lambda times 1 is equals to lambda. Then we have equals to 0. So we're going to have 1 minus lambda. So this is 1 minus lambda. Then 0 minus 0 is equals to 0. 4 minus 0 is equals to 4. Then we have 0 minus 0 is equals to 0. 2 minus lambda. We have 2 minus lambda here. And then 0 minus 0 is equals to 0. Then 3 minus 0 is equals to 3. 1 minus 0 is equals to 1. Then minus 3 minus lambda. We're going to have minus 3 minus lambda. Then this is equals to 0. Now let's compute the determinants of this 3 by 3 matrix. So we're going to have, this is plus, minus, and then plus. So we have 1 minus lambda. Then we are going to rule out this first column and then first row. We're going to be left with this 2 by 2 matrix. And then if you want to find the determinant of 2 by 2 matrix, you multiply the leading diagonal, that is 2 minus 1 times minus 3 minus lambda, then minus 1 times 0. So we're going to have here 2 minus lambda multiplied by minus 3 minus lambda, then minus 1 times 0 is equals to 0. Then minus 0. Now 0 multiplied by anything is equals to 0. So we're going to ignore this 0. And then let's come to this 4 here. So we have plus 4. We're going to rule out this first row and then the third column. So we're going to be left with this. So we have 0 times 1 is equals to 0 minus 3 times 2 minus lambda. So we have 3 multiplied by 2 minus lambda. Now this is equals to 0. So we're going to have 1 minus lambda multiplied by 2 minus lambda multiplied by minus 3 minus lambda, then minus 0. But then 2 minus lambda multiplied by minus 3 minus lambda, everything here minus 0 is still the same thing. Alright, so we're going to have plus 4 multiplied by 0 minus 3 multiplied by 2 minus lambda is equals to minus 3 multiplied by 2 minus lambda. Then this is equals to 0. So you have 1 minus lambda multiplied by 2 minus lambda multiplied by minus 3 minus lambda. Then 4 times minus 3 is equals to minus 12. Then multiplied by 2 minus lambda. Then all of this is equals to 0. So let's factor out 2 minus lambda, because this part of the equation and then this part has it in common. So let's factor it out. We are going to have 2 minus lambda into, now 1 minus lambda multiplied by 2 minus lambda multiplied by minus 3 minus lambda, all of this divided by 2 minus lambda, we'll be left with 1 minus lambda multiplied by minus 3 minus lambda. Now 12 multiplied by 2 minus lambda divided by 2 minus lambda, we're going to be left with minus 12. Alright, now this is equals to 0. So we have 2 minus lambda multiplied by, let's for 1 times negative 3 is equals to negative 3. 1 times negative lambda is equals to negative lambda. Minus lambda times minus 3 is equals to plus 3 lambda. Minus lambda times minus lambda is equals to lambda squared. Then we have minus 12. This is equals to 0. We have 2 minus lambda, then multiplied by we have lambda square. Now minus lambda plus 3 is equals to 2 lambda, and minus 3 minus 12 is equals to minus 15, and this is equals to 0. So you have 2 minus lambda multiplied by, is this thing factorizable? Yes, it is. So find two numbers that when you multiply them, you get negative 15, and when you add them, you get 2. So those two numbers are 3 and 5. Let's assign positive or negative signs so that we get negative 15 and positive 2. Okay, it's going to be minus 3 and 5. Minus 3 times 5 is minus 15. 5 minus 3 is equals to 2x. So we have lambda square plus, let's replace 2 lambda with 5 lambda and minus 3 lambda. So we have plus 5 lambda minus 3 lambda minus 15 equals to 0. So we're going to have 2 minus lambda multiplied by, let's group this like this and this. So we're going to factor out lambda from lambda square plus 5 square. If you factor out lambda, we're going to be left with lambda plus 5. Then we have minus, if you factor out 3 here, we're going to be left with lambda plus 15 divided by 3 is 5. And then this will be equals to 0. So we have 2 minus lambda multiplied by, we have common term here, and that is lambda plus 5 and lambda plus 5. So let's factor it out. We have lambda plus 5. So lambda multiplied by lambda plus 5 divided by lambda plus 5, we'll be left with this lambda here. Then minus 3 multiplied by lambda plus 5 divided by lambda plus 5, we'll be left with minus 3. Then this is equals to 0. So we have that 2 minus lambda is equals to 0, or lambda plus 5 is equals to 0, or lambda minus 3 is equals to 0. Now from here, you see that lambda is equals to 2. And from this one, you see that lambda is equals to negative 5. And from this one, you see that lambda is equals to 3. Let's rename these lambdas here. Let this be lambda 1 is equals to 2. Let this one be lambda 2 is equals to negative 5. And then let this one be lambda 3 is equals to 3. Now this value of lambda are the eigenvalues of this 3 by 3 matrix. Now from these eigenvalues, we are going to find the eigenvectors of this matrix. Now the formula for eigenvectors is equals to matrix A minus lambda I, all multiplied by x equals to 0, where this x and 0 are in vector form. So let's perform the operation. We have A minus lambda I multiplied by x equals to 0. So when lambda 1 is equals to 2, we're going to have matrix A is 1, 0, 4, 0, 2, 0, and 3, 1, minus 3. Then minus lambda. Remember lambda here, lambda 1 is equals to 2. So we're going to use 2 to multiply identity matrix. And if we use 2 and multiply identity matrix, we're going to have 2, 0, 0. 0, 2, 0, and 0, 0, 2. So we have x here. We're going to represent it as x1, x2, x3. Then equals to this 0. We're going to represent it at 0, 0, and 0. Now let's perform this operation. This matrix A minus this matrix. So we're going to have 1 minus 2 is equals to minus 1. 0 minus 0 is equals to 0. 4 minus 0 is equals to 4. Then 0 minus 0 is equals to 0. 2 minus 2 is equals to 0. 0 minus 0 is equals to 0. 3 minus 0 is equals to 3. 1 minus 0 is equals to 1. Then minus 3 minus 2 is equals to minus 5. Then multiply by the eigenvectors, which is these x values. We have x1, x2, x3. Then equals to 0. So let's multiply this matrix out. Minus 1 times x1, we're going to have minus x1. 0 times x2 is equals to 0. 4 times x3 is equals to plus 4x3. Then this will give us 0. Now let's write x3 in terms of x1. So we have 4x3 is equals to x1. Let's divide both sides by 4. This and this will cancel. We will have that x3 is equals to 1 over 4 x1. x1 over 4 is equals to 1 over 4 x1. Now, we're not going to make use of this second row because everything here is 0. Let's go to the third row. 3 times x1, we have 3x1 plus 1 times x2, we have x2, minus 5 times x3, we have minus 5x3. Then this is equals to 0. So we have 3x1 plus x2 minus 5. Now this x3, from here we have that x3 is equals to 1 over 4 x1. So let's replace x3 with 1 over 4 x1. Then this will be equals to 0. Now we have 3x1 plus x2 minus 5 times 1 is, we have 5 over 4 x1 is equals to 0. We are going to write x2 in terms of x1. So we're going to have x2 is equals to 5 over 4 x1 then minus 3 x1. We have that x2 is equals to 5 over 4 minus 3 is equals to minus 7 over 4. Then we have x1. So we have these two equations, I and II. Now from these two equations, let's set x1 to be equals to 1. So if x1 is equals to 1, we have that x2 is equals to minus 7 over 4, and then x3 is going to be equals to 1 over 4. So we have that the eigenvector when lambda 1 is equals to 2 is equals to x1 here is equals to 1, x2 is equals to minus 7 over 4, and then x3 is equals to 1 over 4. But we are going to multiply everything here by 4 to get rid of all these fractions here. So you have that the eigenvector x1 when lambda 1 is equals to 2 is equals to 4 times 1 is equals to 4. 4 times minus 7 over 4. This and this will cancel. We'll be left with minus 7. And then 4 times 1 over 4 is equal to 1. So this here is the eigenvector of this matrix when lambda 1 is equals to 2. So let's go ahead and solve for the eigenvectors when lambda 2 is equals to negative 5. So when lambda 2 is equals to negative 5, we are still going to use this equation here. We have that a is equals to 1, 0, and 4. We have 0, 2, 0, and 3, 1, minus 3. Then minus lambda times identity matrix. Lambda 2 here is negative 5. So we're going to have negative 5 times identity matrix. We have negative 5 here. Then 0, 0, we have 0, negative 5, and 0, and 0, 0, we have negative 5. Then multiply by the x1, x2, x3, all of this will be equals to 0. So we have 1 minus times minus is plus. 1 plus 5 is equals to 6. Then 0 minus 0 is equals to 0. Now 4 minus 0 is equals to 4. 0 minus 0 is equals to 0. 2 minus 5 is same thing as 2 plus 5, which is equals to 7. 0 minus 0 is equals to 0. 3 minus 0 is equals to 3. 1 minus 0 is equals to 1. Minus 3 minus 5, same thing as minus 3 plus 5, which is equals to minus 2. Then multiply by x1, x2, x3 equals to 0. Now this is going to be equals to 6 times x1 is equals to 6x1. Then 0 times x2 is equals to 0. 4 times x3 we have plus 4x3. Then this will be equals to 0. Now to the second row, you have 0 times x1 is 0. 7 times x2 we have 7 times x2. Then 0 times x3 is equals to 0. So all this will be equals to 0. Then from the third row, we have 3 times x1, 3x1, then plus 1 times x2, which is equals to x2, then minus 2 times x3, minus 2 times x3, then this will be equals to 0. Let this be equation 1, equation 2, and then this equation 3. Now from equation 2, you have 7x2 is equals to 0. If you divide both sides by 7, this and this will cancel. We have that x2 is equals to 0 over 7 is equals to 0. Now from equation 1, we have 6x1 plus 4x3 is equals to 0. This 6x1 plus 4x3 is equals to 0. Now let's write x3 in terms of x1. So you have 4x3 is equals to minus 6x1. Let's divide both sides by 4. Then this will cancel. We have that x3 is equals to, now 4 divided by 2 is equals to 2. 6 divided by 2 is equals to 3. So we're going to be left with minus 3 over 2 x1. Now let's set x1 to be equals to 1. If x1 is equals to 1, then x3 is going to be equals to minus 3 over 2 multiplied by 1. Then x3 is going to be equals to minus 3 over 2. So I have that x1 is equals to 1, x2 is equals to 0, and x3 is equals to minus 3 over 2. Then the final answer is that the eigenvalue when lambda 2 is equals to negative 5 is equals to 1, 0, and minus 3 over 2. Now I'm going to multiply everything here by 2 to clear this fraction. So we have that the eigenvector when lambda is equals to negative 5, that is lambda 2, is equals to 1 times 2 is equals to 2, 0 times 2 is equals to 0, minus 3 over 2 times 2 is equals to minus 3. And so this is the answer. Let's solve for eigenvectors when lambda is equals to 3, that is lambda 3. I want you to pause this video and try this one out. Just solve it. So when lambda 3 is equals to 3, we're still going to apply this equation there, the formula. So A is 1, 0, 4, 0, 2, 0, and 3, 1, minus 3. Then minus lambda is 3. So 3 times identity matrix, we have 3, 0, 0, 0, 3, 0, and 0, 0, 3. Multiplied by, we have x1, x2, x3. Then this is equals to 0. So we're going to have 1 minus 3 is equals to minus 2. 0 minus 0 is equals to 0. 4 minus 0 is equals to 4. 0 minus 0 is equals to 0. 2 minus 3 is equals to minus 1. 0 minus 0 is equals to 0. 3 minus 0 is equals to 3. 1 minus 0 is equals to 1. Minus 3 minus 3 is equals to minus 6. Then multiply by x1, x2, x3 equals to 0. So let's form the equations. We have minus 2 times x1. This is minus 2x1. Then 0 times x2 is 0. We have 4 times x3 plus 4x3. Now this is equals to 0. Then from the second row we have minus 1 times x2 is equals to 0. I have minus, that is minus x2 is equals to 0. Alright, so we don't need any other equation. So from this second equation, we have minus x2 is equals to 0. If we divide both sides by minus 1, we have that x2 is equals to 0 by minus 1 is equals to 0. Now let's focus on this equation and make x3 separate to the formula. We have 4x3 minus 2x1 is equals to 0. So this is 4x3 is equals to 2x1. Let's divide both sides by 4. This and this will cancel. We have that x3 is equals to 2 divided by 2 is 1. 4 divided by 2 is 2. So we have 1 over 2 x1. Now if you set x1 to be equals to 1, we have that x3 is equals to 1 over 2 times x1, which is 1. 1 over 2 times 1 is equals to 1 over 2. So we have that x1 is equals to 1, x2 is equals to 0, and x3 is equals to half. Now, the third eigenvector when lambda is equals to 3, which is lambda 3, is equals to x1 is 1, x2 is 0, and then x3 is 1 over 2. Now let's multiply this by 2 to clear this fraction. So we're going to have that the third eigenvector is equals to 2 times 1 is 2, 2 times 0 is 0, 2 times half is equals to 1. And so this is the eigenvector when lambda is equals to 3, that is lambda 3. So this is how to determine the eigenvalues and eigenvectors of a 3x3 matrix. Thank you for watching. Please don't forget to subscribe to this channel, like this video, and share with your friends. Enjoy the rest of your day.